Good morning everyone, this is Manoj. So in the next 2-3 minutes we will take a look at defect prediction. Ever wonder how easy it would have been if we were able to predict the defects that could have crept in while we developed any software? So the defect prediction model that we are talking about uses techniques like AI and machine learning or algorithms based on machine learning. Traditionally, from a testing perspective, testers get involved during the testing phase or once the build is almost done. And there is so much that happens before that. There is this requirement phase, there is this design or architect phase, there's a build where the developers sit and code your system, and then there is this test phase. And while this happens, testers rarely have a visibility into what exactly went into the making of the system. Where did the developer struggle so much? Which area or which modules did he recompile so many times, retest so many times, rewrite the code so many times? And all this information is present in the log files, if the log files are enabled. So log files are a good source of information as to how did the application or system develop. What happened during that build phase? What went into the making of one, right? Similarly, there are other aspects like the source code. The source code gives us a lot of information about the application growth, historical data, application ecosystems, environments. These are the other aspects from where you can get insights into how great or how good an application are you building it. So in this case, we will just focus on the first one, say log files, for example. So we are talking about an engine that takes log files as input, and this engine, of course, it is AI and machine learning based. The engine, the first component is a pattern recognition algorithm, which identifies patterns or error patterns, warning patterns from the log files. It clusters that and it classifies that and it maps those errors into modules or applications or subsystems. In short, the engine will tell you which 20% of the modules are causing 80% of the issues for you. And in other words, it is pinpointing the weak spots. And once they are pinpointed, you can automatically trigger automation scripts, be it QTP, Selenium, Test Complete, any of those scripts. So the entire thing can be done in an unattended manner. You feed log files, your engine goes in, identifies the patterns, identifies the weak spots, maps it into some modules, and automatically triggers automation scripts at the backend. Intelligent scripts which runs in an unattended manner. Or in other words, we are talking about a next generation automation suite which knows what to test, when to stop testing, and whom to report these defects to, provided it is configured. So that's all I had today on the defect prediction model. Thanks everyone.